Hi, good evening, everyone. Can someone confirm if I'm audible?
Yes, sir.
Okay, yeah, thanks. So maybe it's already 6, so maybe we can start in a minute or so. So welcome to the live session for week 10 for the course Digital Circuits, which is taught by Professor Shantanu Chattopadhyay from IIT Kharagpur, and I am Anant Singhal, a PhD student from IIT Jodhpur. And today I'll be solving some of the similar assignment problems that have been given to you in the week 10 assignment. That is mostly related to I think the microprocessor part or some of the FPGA questions are there. So we'll try to cover some of those. I think it's more or less related to your VHDL lectures that are being covered in week 10 itself. So uh, we'll be going towards that, and we'll take a very brief overview of uh, about the history of this VHDL. Some of the questions can be related to that, and then we'll be discussing some of the 8085 microprocessor problems that are there in your week 10 assignment. So as you can see, we have already covered almost complete part of the course that is more or less related to the conceptual part. Now the microprocessors that we have is more or less uh, like they could be conceptual, but yeah, they are more or less theoretical because of their nature. You can easily or you can easily understand it just by going through the lectures or the theoretical lectures. So the problems that you will find in these particular topics will be more or less easier as compared to, let's say, a problem on combination or a sequential circuit that we did in our last lecture, or that we kind of completed in our last lecture with the memories part itself. So yeah, without waiting much, let's start to some of the problems that we have for this particular week. So since the problem will be easier and quite straightforward, I'd like to request all of you to please all of you type your answers in the chat box so that we can move quickly in this particular lecture, and it could be a like a shorter lecture, maybe an hour or so might be sufficient to cover this particular lecture. So I request everyone to quickly type your answers in the chat box as soon as you see the problem in the screen. Okay, so the first problem is related to the VHDL and Verilog. So the problem is asking what are these? Are these software description? Are these assembly? Are these hardware description or the machine language? So yeah, you all are correct. Those who are saying C. So both of them are hardware description language. Okay. Yeah. So both of them are hardware. As the name suggests, in VHDL, the HDL stand for hardware description language. And we have this VHDL. So this V itself has a long acronym which is VHSIC, which is very high speed integrated circuit hardware description language. So yeah, let me write that also. Okay, sorry. Yeah, in Verilog itself. So like as a part of my PhD itself, I use a lot of Verilog language for the modeling of the devices. So like I'd say it's a very important topic as if you are very keen towards VLSI jobs. So even Verilog is more used as compared to the VHDL language that is I think a part of the course. So I'd recommend you all to, if you want to have, I mean, some, if you are looking out for jobs opportunities related to VLSI, you should also consider like studying this Verilog language in details, because this is the key language that we in general use for the device as well as the circuit description. So yeah, so the correct answers for this problem will be option C.
Sir,
Yeah.
sir, there is OS is there, no, sir? Like C plus
So
like there, no, sir?
your
Are
voice just,
they made by this, sir?
can you speak a bit louder?
Sir, this C language, Python
Yeah.
language, they are all there, no, sir.
Yes, yes.
This C language made out of Verilog, sir.
No, no, no. It's the opposite way. So there is a question related to this, maybe the next problem itself. So it says which programming language has been utilized in the development of Verilog HDL? So yeah. So as you asked that if C language has been made out of this or not, but it's the other way around. So using the C programming language, we have made or we have developed the Verilog HDL language. So the correct answer to this problem would be option B. So like as you said, we have Java, we have Python. So we have taken a framework of C programming, like the syntax of the C programming, to develop this Verilog HDL language, because again, C is very easier to read. We can able to understand what is the circuit, what is the implementation that has been done, like a current or a voltage source. So we in general use C language or C programming language standard or the syntax of that to develop the Verilog HDL codes. So this Verilog HDL is not VHDL. I'd like to be clear. So Verilog HDL means Verilog language only.
सर एडीए लैंग्वेज और जावा और पाइथन व्हाट इज दिस सर ये
Sorry.
सर ये जावा पाइथन और एडीए लैंग्वेज इसके बारे में थोड़ा बता दीजिए
Yeah. So okay. So that is more or less like if you want to go into the programming part. So currently the most of the programming that have been used or you might have heard about like algorithms such as machine learning, etc. So the most popular language currently is Python because it is very user friendly. It has a very easier syntax to read. Then some like few time back, Java was the most prominent one, and it is still used in the web development if you have heard about it. And this ADA language is like it is named after a scientist called as ADA itself. So ADA is the scientist name. So using the ADA language, actually that is the next question. So the question is, what programming language has been utilized in the development of VHDL? So VHDL has been derived from this ADA language. So ADA is the name of a scientist after which this language has been named. And in VHDL, we use the syntax of the ADA language to implement circuits. So I think we'll be seeing some of the syntax of the VHDL in the subsequent question that will help you understand. But yeah, the basic idea is these are all different languages having different types of application.
Sir,
Yeah.
sir, I mean, in C language, we have syntaxes now, sir, like scan, print, like that
Yes.
there are
Yes.
no, sir.
Yes.
Behind, when I am typing print in keyboard,
Hmm.
when going to hardware, which they will use, sir? I mean, like this, how we, when going to the circuits, logic circuits,
Hmm.
this print word is converted to which language, sir? I mean,
No, print remains print.
how?
So, for example, you're writing, let's say, a Verilog A code or a Verilog code, sorry. So, in that, if you want to print, let's say, a variable, I mean, I can give you a very easy example. Let's say, in Verilog, what we do is we define the current source, and the assignment operator is something called as less than plus. So, this is equivalent to a equals to. Let's say we are writing some, maybe, so let's say V by R because it's the Ohm's law, right? So let's say if you want to print current, so it will be like this, print I, because the syntax of C is like that. So you can print that maybe on the netlist level, but yeah, it is still doable on some level. So if that is what you're asking, so we can still do that in the Verilog language or the VHDL language. So I'll show you a snippet maybe from a question, how exactly do we write. So we have some difference. We are like the utilization of this. So it says the utilization of the development. It's not saying that we can write a code in C and it will work in the VHDL. There are some differences, but yeah, the basic idea or the syntax that has come from is it has come from C programming. So for example, let's say if you see the next problem, it says choose the correct entity. Yeah,
but which type of editor we can use to convert that
which kind of
program
what?
which types of editors
Oh, we don't need any editor. We need to learn some of the keywords that are there. For example, let's say in this problem, you see entity port. So these are all the keywords that you need to learn to implement a circuit. So like we can see, so this is kind of a syntax of a VHDL code in which you need to, so and is the syntax, let's say in C programming, you should have heard it already. or you should have been. So there are for loops, there are if loops, so they are still there in this language also, but there are certain more keywords. So you need to learn to implement the circuits. For example, a entity is nothing but a complete circuit, that is the box that we are dealing with. So let's say this in this particular problem, this design that you see is the box. So that is the entity. I mean, the whole circuit is called as the entity. So this is the keyword that you will start your program with. And then port means each and every input port needs to be defined in this port variable. Like in your C programming, let's say, what example can I take? So I'm not sure if you are already aware of the C programming, but there are functions, there are classes in which you define some of the variables, such as, let's say, there is a class or there is a function, maybe named as something ABC, and you define a variable A. So this can be either integer, this can be either real variable. I don't want to go in very detail because you might not be aware already of these programming languages, but yeah. So the port here represents the all the inputs and output ports of this particular. I mean, port is a keyword that you need to learn to implement this circuit. Then end is the, so entity design here it started, and end design is the ending point. So this is how you write. I mean, this is a basic example that will help you understand. So in this circuit, exactly, if I can say, you see, it's like a half adder, right? So we have two inputs which are A and B. So we can clearly say that A and B are inputs, right? And sum and carry are the outputs. So now in each of the option that you see, A is written as the in bit, B is written as the in bit. So here also A is, B is in bit. So A cannot be the output because it's the case, and so option C cannot be correct. Now sum and carry are both the output ports, right? So sum cannot be the input, so this is also wrong. Sum and carry are the output ports, so this is correct. And the entity is also named as design, which is correct. So option B is the correct answer to this problem. Again, you will see in cannot be the sum and carry, and in again cannot be the sum, and carry cannot be boolean, it is actually a bit variable. So boolean means true or false, like a comparison. So option B is the correct answer to this particular problem. Yeah, is there any doubt?
Yes, sir. Sir, I have a doubt. Like we have a number 434. How could be converted Boolean number?
Sorry, how could we what?
How could be converted in Boolean number like 434? What is that Boolean number?
Oh, okay, okay, I understand. So 434 itself, like it's 2 to the raised per 7 8, so it's like around 2 raised per 9 approximately. So it will be a 9-bit boolean variable which will be something like 10101111 and something like that. So I'm not converting exactly, but yeah, this is the boolean formation or the binary formation of this. Is it fine?
Sir, but I was tried to that number is Boolean number is 10110011.
Okay, sorry. Can you repeat 10 what?
10
Hmm.
110001. That are the come in my output.
Okay, so you're saying this is your output if you're giving 434 as an input in
Yes, sir.
decimal.
Yes, sir. Decimal.
Okay, so I think yeah, we can calculate that. So this will be 1. Okay, so let's just quickly calculate this. So it could be 1, 2, 3 is 8 plus 16 plus 52 plus 64. So this is actually not 434. You might be doing something wrong if I'm not wrong. So this is 89. So this is actually 89 in base 10. So 434, I'm not sure how exactly are you doing it. So it could be in some different, I think, base value. So it is not a decimal. So this particular number belongs to the 89 in decimal. So you need to correct that, or maybe you can share wherever you have implemented this. I can take a look, and I'll mail you later about your mistake.
Okay, sir.
Yeah. So yeah, maybe since we have done a problem like this, so okay, wait, yeah. So this is again a similar problem that is related to the VHDL Maybe if you already have the idea about the sensitivity list, you can let me know your answers in the chat box. Maybe I'll wait for 1 or 2 minutes and then we can do it together. Okay, I think you have not studied about this. Okay, fine. So it says the what signal should be included in the sensitivity list of the process construct for a given combinational circuit. So as we have just seen that this particular circuit can have a VHDL code which could be written. So there is one thing that is called as entity that we have already defined in the previous problem also. So if I try to write, so let's say this will be designed. So I'm calling this as half header, for example. So let's say this is half header, and again we'll use the same thing, which is port. So first port is A, which is the input port and it is in the form of bit. Then B is again input, which is again in the form of bit. Then we have a variable named as sum, which is out. And then we have a carry, which is again out. So yeah, we'll just close this and then we'll have that end design or HA. So this is what we have already seen. So this is one construct which is basically used to define your circuit. Now we also have a process construct that is being given in the question, which is this. So in process, in the bracket, we write those variables. So it contains a sensitivity list. So what does it mean? It means the variables. Okay, wait. Which are either used in comparison statements. I'll give you an example that will help you. Or are at the RHS right hand side, that means of assignment statements. So what I'm trying to say is, so if you write this code in VHDL, for example, let's say for the variable sum and carry, so you'll write in the main part, you'll write begin, and in begin you will write sum is assigned as, so this is assignment operator for VHDL, less than equals to, sum is assigned as A XOR B. This is the syntax. Then carry is assigned as A and B. And then we'll end this. So now what are process or what are the sensitivity process parameters? So there can be two things. Either they are on the right hand side. So right by right hand side, I mean this right hand side. Whatever is there right of the equals to is the right hand side. I think you already know that. You all should have the idea. This is the basic mathematics. So whatever variables are there in the right hand side or whatever variable are there in the comparison. So comparison could be like if A is greater than B, then the output should be something. So these are the comparison variables. So this could also be in the process list. So for this particular example, we do not have any comparison, but we do have two variables which are in the right hand side. So the process will contain A and B. So the correct answer to this problem will be option A. Is it clear to everyone? Okay, great. Okay, maybe
सर अगेन सर इस बार फिर समझाइए सम कैरी क्यों नहीं होगा सर ये सी आंसर
some carry is on the left hand side of the assignment, right? So as I said, the process construct only contains the variable which are on the right hand side of the assignment statement. So right hand side we only have A and B.
ओह
Yeah. So there could be one more case where we have the comparison statement. So for example, let me try to give you example that will help you. So let's say if I write maybe Okay, I'll give you example later. I think I have a question related to that that will help you in understanding. But yeah, this should be clear about the right hand side of the assignment. So yeah, maybe we can move ahead. Yeah, so this is the next problem. Which of the following statements is true? So if you have the idea, you can write your answers in the chat box. Maybe I'll give you a minute or so, and then I'll try to explain if you already don't know.
Hello.
Yes. Okay. So I think, okay, let me try to explain. So the question says which of the following statements is true? So we have two terms here. One is a signal, one is a variable. So it says signal do not have the notion of event scheduling. And there is one more term which says variables follow the notions of event scheduling, and then again signal follows the notion. So let me try to explain you the basic difference between a signal and a variable. So this is more or less related to syntax again. So in a signal, we what we do is we do assignment using, let's say we have x and y, something like that. So we do assignment as we were doing in the previous problem. So basically a signal represents, let's say we have a box in which we have x and a y. Okay, so in this case, maybe I'll write it like this. So signal represent that there is a interconnect, like there is a wire that is actually connected between x and y. So let's say you are getting, maybe output is, okay, so yeah, so input is x. So if there is an interconnect which is called a signal, so if you are having your input at t, your output will be at some delay d plus dt. So there is some scheduling or there is some dependent upon the time. So signal always follows event scheduling because there is a time factor involved. So the correct answer to this problem will be option C. Now if I talk similarly in terms of a variable, so variable, first of all, it is defined, instead of defining it like that, variable is defined by colon equals to. That means it is instantaneously available, like there is no interconnect, physical interconnect. So it is instantaneously available to you. So there is no time factor involved. For example, let's say if I take, maybe I'll try to give you example. If I try to take maybe two inputs as we are doing one output. So if I write maybe y, which is the output, which is, let's say, equals to a, yeah, for example. So that means there is a signal or there is a actual wire that has been connected in between that. So this is also called as interconnect. Sorry. Yeah. And if I do the same thing, or if I, let's say if I write y colon equals to a, then there is no interconnect. This y is really readily available. Whatever the value of a is there, it will not process it through this particular interconnect, but it is readily available. So this is a variable and this is a signal. So if I try to maybe make a quick table out of it or a quick comparison, so these both can be varied based upon three major things, which are, first of all, the assignment, as we are already seen that how they're assigned. Second is the utility part, and third is the behavior of these. So yeah. So signal, as we have just defined, that we write it in a form of like assignee, maybe it can be xy less than equals to assignment, right? And this could be assignee colon equals to assignment. Then the second thing could be utility. So utility means it represents a circuit interconnect. As I just said you, there is a actual wire and there is some delay, and it is following the event scheduling. Wherever this is like a storage, whatever is there is just giving out you the value of that. It is not processing anything. Then third is the behavior, which is basically, so how it works is it gets updated at the end of the statement because it is processing. Wherever this is updated immediately, whatever value you are assigning, it should be there without any processing. So these are the three key difference that you will see in a signal and a variable. But yeah, just to have your clear idea about the event scheduling, it is only dependent, the signal is only dependent upon the time, but it does not depend upon time, the variable. So the correct answer to this problem was, that is why it was C, that signal follow the notion of event scheduling. Is it fine? Does it make sense? Okay, so let's move ahead. Again, more theoretical question kind of. Please type your answers in the chat box quickly. You should have already known these things by your lecture. Yeah, so the correct answer is option B. So the VHDL language is actually developed by the US Department of Defense, and it is developed on the ADL language, as I have already told you in the first or the second problem, which is again a scientist, which is the language is named after. This was a straightforward question, so I think we can move ahead. Okay, so this is the next problem. Again, take 2 minutes and let me know the answer. Okay, no idea. Fine. So it says logic synthesis is a process of So basically, the logic synthesis is nothing but a process of converting the behavioral level description to the structural level netlist. So the correct answer is option A. The if I try to explain it in a very easy language, so what we are doing is we are writing this, right? Sum is nothing but A XOR B, and then we are writing carry as A and B. So this is actually how a program is actually understanding, that is using the logic synthesis. So what logic synthesis is doing is structural level netlist means implementing the actual circuit. For example, if I try to implement this only, let's say this is A B, this will be the sum, and then A B, this will be the carry. So to change this structural level netlist into this, so this process is nothing but logic synthesis. This is an internally by the machine. So it, by doing this process, it is able to understand that this sum is actually the output of a circuit which is given by A and B, and doing the XOR operation on them. So XOR is a keyword. So once you do A XOR B, your sum will be given out as an output of the circuit. So this is actually what the process of logic synthesis is. It it is a process of converting the behavior level description to the structural level netlist. So option A is the correct answer. I think these are two, I mean, theoretical question I do understand. Maybe I have, yeah. So these are some questions that will require some knowledge now. So it says, as I said, so it has given you a process construct of a circuit, and it is asking which type of circuit is it. So maybe, yeah, maybe just try to implement the circuit. It's very easy to understand just by giving the way it is given. So if you are able to do it, please type your answers in the chat box. You can take maybe 2-3 minutes for this, because this is actually a good question. Uh, any idea, anyone? I think this is pretty easy to understand just by. Okay, so I have one answer which is B. Okay, let's see. Yeah, so actually B is the correct answer. Okay, as I said that the process construct only contains a variable which are either on the comparator or comparison or on the RHS of the assignment. So you see here the RHS of the assignment we have A and B, and there is a comparison statement which is in which S is involved. So this is one example that could have explained you that why A, B and S are in the process construct. So now the problem says that we have A and B as inputs, and it says we have a single output which is Z, and it depends upon if S is less than 1, oh sorry, less than not, but if S is equals to 1, then A is your output, so basically this will be A, and if it's not, then B is the output. So it's like a 2 cross 1 multiplexer, right? Are you all able to understand this? So what it is saying is when S is 1, your output is A, right? Yeah, and if S is 0, your output is BO. So I've written it wrong. Yeah, it's like that. So this is nothing but a multiplexer. Are you all able to understand this? This is a most basic problem that you should understand. Can all of you confirm if you are able to understand this? If yes, maybe I can try to give you one more problem which is similar, which I don't have here, but yeah, I can type for that. Okay, so try to give me the answer to this. So the problem is, let's say I have given you both entity code as well as the process code. So let me write that. So my entity code is entity design, and I have ports, and ports that are given are A, which is nothing but a input port, which are having bit 1 down to 0, and I have B, which is again an input bit which is 3 down to 0. So 1 down to 0 means 1 and 0. That means, I mean, this is 2 bit. 3 down to 0 means 3, 2, 1, 0. That means this is a 4 bit. Okay, sorry, this is input and this is output. So this is the port definition, and we have end design. Now in the process construct, what is given is, we'll write it separately. So it says begin. So I have a process in which only A is written, and it says, okay, so begin should come afterwards. It says begin. So now it says if A is double equals to 0, 0, then B is equals to, okay, not equals to, but B should be assigned. So it should be assignment variable. So B should be equals to 0, 0, 0, 1. Then the next statement is else if A is equals to 0, 1, then B is assigned to 0, 0, 1, 0. Then we have else if A is equals to 1, 0, then B is assigned to 0, 1, 0, 0. Or last statement is whatever else is A, B is 1, 0, 0, 0. So yeah, I'll do the end if, and then I'll do the end process, and then I'll do the end begin. Yeah, just end this. So this is the whole code. One is the entity design in which your inputs and outputs are defined, and then the working of the circuit is defined in the process. So you need to find out which kind of a circuit this is, or which kind of a combinational circuit this is. Like the previous one was a multiplexer, so you need to tell me what kind of a circuit is this. Are you all able to understand the problem? Okay, so yeah, please let me know. Take your time, maybe 2 minutes, and then write your answers in the chat box. I'm not giving you any options because that will make it very simple. Yeah. So yeah, this is the actual working of the circuit. Take maybe 2-3 minutes and type your answer in the chat box. And ask again, are you able to understand the problem? Because this should not take time. If you're able to understand the circuit, then yeah, it should not take time. So maybe take 2 more minutes and let me know what do you think about the circuit. Still no answer? Okay, let me try to explain then. You should have answered this if you are able to understand the previous problem. So it says we have one input port which is of 2 bits, as I said, and it has one output port which is of 4 bits. So can I make something like two inputs, which is let's say A0, A1, for example, and it has four outputs, which I can say B0, B1, B2, B3. So this is some circuit that it is pointing out towards the entity, which is it is something design called as design. And now the working of this, it says that when the, so if I can try to make the truth table, so B1, B2, sorry, this will be B0, B1, B2, B3. So it says there can be four possibilities. So it says when it is 0, 0 here, so output should be 0, 0, 0, 1. Okay, I should have written this the other way around. So MSB should come first. Same for this. The second it says 0010. The third it says 0100, and otherwise it is 1000. So this is the truth table and that is the circuit. Are you still not able to figure out what circuit is this?
Sir, decoder.
Yes, exactly. So this is a 2x4 decoder. So this is the correct answer to this problem. It is a 2x4 decoder. So by writing these words, you are able to implement a 2x4 decoder in your computers. This is how we do it. I mean, if I was just trying to give you idea. Similarly here, if you have also seen that here there was two conditions, so we could have easily seen that there is a select line, so there it could be either a multiplexer or a demux, and there is a single output and multiple inputs, so that already confirmed that we have a multiplexer. So since there were only two outputs, so there it is a 2 cross 1 multiplexer. And similarly here we had two outputs, 2-bit outputs, that is already defined here, and 4-bit out. So this only could have given you the idea that it is something called as a 2 cross 4 circuit. And then the operation was showing that it is a decoder, that it selects based upon the input. Is it fine, everyone? No. Good. So let's move ahead. Okay, so now we might have some problems on 8085 microprocessor now that is a part of this week also. I have seen your assignment and I've seen some problems that are related to your 8085 microprocessor. So we'll do some problems in this particular week. So yeah, this is the problem. What is the instruction set side of a 8085? So please do type your answers in the chat box quickly. You should have already studied it in the lecture, if I'm not wrong. So we have this 8085 microprocessor in which we have 8-bit, which is a 8-bit microprocessor. And okay, let me give you a basic idea. So it has 244 commands. That means it can do 246 different operations, and the total instructions that it has is 74. The correct answer to this problem was option A. And by instruction, what do I mean? For example, let's say, so there is a syntax again to use the 8085 microprocessor. So we write, for example, let's say A add B. So this add is the instruction. So like add, we have 74 different instruction, and we have in total 244 different commands. So yeah, so now the conversion of this human language to the complex machine language is done using a equipment called as assembler. I mean, I'm just giving you the basic. You can go through the lectures there. It is like very theoretical topic, so you cannot explain much. I can just give you the details what I know. So we have total 74 instructions and 246 commands to go with, and the conversion of the human readable language to the machine language is done by a component called as assembler. So yeah, option A is the correct answer to this. We do have 74 instructions in the 8085 microprocessor. So let's move ahead. So now it says which of the following is not a part of 8085 microprocessor. Okay, so this option is not correct. It should be ALU. Yeah. So try to give me the answers again. Maybe you can take 2 minutes. This is again a very easy problem. Have you not seen the lectures? I think week 10 is already out last week. So these problems are very easy. I mean, I'm expecting a lot more answers. So yeah, a microprocessor does not itself contain a
A
CPU or a
GPU.
yeah,
GPU.
yeah, exactly. So a CPU or a GPU itself contains a microprocessor with different elements. So yeah, a microprocessor only contains a ALU, which is a arithmetic logical unit, a control unit, and registers. So GPU is the correct answer because it is not a part of that. Yeah. So let's move ahead. It says, what is the primary function of a microprocessor assembly language? I just told you. So let me know the answer.
And then it's C.
Okay, so there is no way that we can communicate with hardware devices or anything can communicate with hardware devices. I told you that the assembler or it converts, you can say, a human readable language into a language which is readable to hardware. So exactly the primary function of the assembly language is basically to provide a low level programming interface. That is, we can write something in a very easy way and the machine could be able to understand that. So the assembler is basically helping you in writing that code in a syntax that is being understood by you or the human, and the assembler, what it is doing, it is converting it to a binary equivalent of that basically, so to be so that we can have the actual instructions that are being performed. So what I'm trying to say, so there are instructions that you are writing and they are being converted into some binary instruction so that machine can understand this. So the correct answer to this problem is option D. So let's move ahead. Now it says, which component is responsible for converting assembly language code into, okay, so I think I've already told you, but yeah, write your answers in the chat box quickly.
Answer C, assembler.
Yeah, so I just told you that whatever instruction we write, it is converted into machine code by a assembler. So option C is the correct answer. So if I give you a very basic idea about all this, so compiler is nothing that transfer or that translate the entire code that we write into a machine language. So compiler, what it does, it translate the entire source of code. So for example, in C or Python, that is what we do, that we, you might have seen if you have ever done a programming. So we initially compile the code and then we run the code. Then a
सर
link.
कंपाइलर और इंटरप्रेटर का क्या काम है?
Yeah, I'm telling you that only, that compiling is basically converting the entire source code into a machine level language or an intermediate code, that we are checking the program for if there are any error or not before actually converting it to a machine level language. Whereas interpreter is, it is like, it is directly executing those instructions that we have written. So uh, for example, let's say we have a code which is of 10 lines, so compiler do the checking for the whole code, as I said, whole source code, whereas interpreter solve equation one by one. So interpreter will go one by one. So it's basically executing execute statement, one statement at a time, unlike a compiler which is basically translating everything and runs the code concurrently. And then yeah, linker is just used for linking. I mean, it is the name is already there. So the correct answer is to convert assembly language into machine code, we require a assembler. So option C is the correct answer for this problem. Okay, let's move ahead. Yeah. So in the context of a microprocessor, what is a mnemonic? So again, maybe I'll give you 2 minutes. Type your answers in the chat box. You have already got one. Yeah, see. So yeah, actually mnemonic is nothing but a symbolic code representing an instruction. So whatever we were writing, as I was writing, maybe A XOR B or A add B. So this is just a symbolic representation, as we said. So the machine language is actually getting converted by assembler. So these both are mnemonics. Sorry. So this is how we spell it, mnemonic. The correct answer is option C. Let's go ahead. So it says 8085 microprocessor is a some bit general processor. Yeah, so I've already told you
8
that.
bit, 8 bit, sir.
Yeah, so it is a 8-bit microprocessor, and we know that, I mean, some of the idea if I try to give, so it has a ALU, it has some memory, which we call as registers, and it is 8-bit, so it has like 8 bits. So we have a which is called as accumulator. I'll maybe some problems are there in the next week lectures, that is week 11. So I'll try to solve those problems if that will able to understand you better. So it has 8-bit registers. That is why it is a 8-bit general purpose processor. And yeah, so every time we are having some arithmetic logical operation happening, then we have some memory that we can transfer here and there. So yeah, this is like a microprocessor. So it is a 8-bit microprocessor. Why? Because it has 8-bit registers.
अच्छा सर, ये कभी कहीं कहीं 16 बिट भी कुछ दिया हुआ रहता है, तो क्या है वो चीज सर, 16 बिट जो रहता है?
Yeah, 16-bit what?
तो इसी माइक्रो प्रोसेसर में पढ़े हैं 8085 में कि 16 बिट का कुछ दिया हुआ, वो किस क्या है सर?
Yeah, so that are actually the address lines. So I'll explain that using the pin diagram. Maybe just give me a few minutes. There is a pin diagram. I'll explain it in the next problem.
अच्छा ठीक है
Yeah.
सर, ओके।
So yeah, moving ahead towards the next problem, we have what is the total number of pins in a 8085 microprocessor?
40।
Yeah, so we do have 40 pins in a 8085 microprocessor. So now, as you said, that there are something that is being given as 16-bit. So this is the actual pin diagram of a 8085 microprocessor. So if I start with, maybe let's say, let's zoom it. So we have x1, x2, which are something frequency dependent pins. I mean, yeah, some of the operational pins. Then we have some different operations such as reset, trap. So we'll try to explain, I mean, cover these in the later class in which there are actual problems related to that. Then we have these address lines, address data bus, as you can see. So you see it is AD0 to AD7, right? So these are the 8 bits of address data bus. And according to these, there are also this address bus, which is written as A, sorry, not A, it is written as A8 to A16. I mean, not 16, but 15. So these are in total 16 lines. So that is what I think you were referring to. So we have, okay, wait. So I think I've written it here. Yeah. So we have AD0 to AD7, and we have then A8 to A15. So this is the whole, what I can say, address lines, or a 16-bit address, you can write this as. And in these 16 bits, these AD0 to AD7 are the actual 8-bit data. So that is why you see some where 16 things are given or 16 bits are given. So the first 8 bits are the actually 8-bit data bits. Is it understood?
Yes, sir.
Yeah, and then we have some more operations like we have read, write, etc., ALU and all. So yeah, so this is actual pin diagram, and this is, I mean, we'll do some problems maybe later in the next lecture if there are any problems in the week assignment, week 11 assignment that are given to you. So we have in total 40 pins. Some are like made for some different purposes, but yeah, these 16 are the total address lines, out of which the first 8 is the 8-bit data, and they are all stored using registers, right? Memory. So yeah, let's move
इसमें
ahead.
इसमें इस इसमें 16 बिट एड्रेस हो गया सर, और 8 बिट डाटा हो गया।
Yes,
और रजिस्टर पूछेगा कि कितना रजिस्टर, तो सर 8
8
बिट।
bit. Yes, 8 bit.
ओके सर।
Yeah, so let's move ahead. So it says, what is the purpose of ALU? So I mean, it's very easy. Please type your answers in the chat box.
सर ए टू परफॉर्म मैथमेटिकल ऑपरेशन।
Yeah. So this is actually the operation of ALU. Then we have to control memory access or to manage program flow. So this is done by the control unit, which is also called as CU. And to store data, it is registers. So basically, these are the three main component of a microprocessor. One is ALU, one is control unit, and the third is registers. So this is for storage. Sorry. This is for control the memory access or the flow. So I'll write the flow. And this is for mathematical operations. Or it's mathematical as well as logical. I hope this is very easy or clear. So option A is the correct answer to this. Okay, so let's move
सर
ahead. Hmm.
सर अभी तक जो आप लेक्चर सर ये हम लोग को बताए हैं, ये सब कहाँ पर सर हम फिर देखना चाहेंगे तो कहाँ मिलेगा?
अभी सब क्या बताया है?
सर जो भी अभी तक 11-10 असाइनमेंट तक जो लेक्चर अभी हुआ है सर, डिस्कशन हुआ है, ये सर टोटल कहाँ पे मिलेगा अगर हम फिर से दोबारा देखना चाहेंगे तो?
You mean the videos?
जी सर।
Yeah, so they are uploaded on the YouTube channel. I have already given it in the first class. So maybe you can search my name on YouTube, Anant Singhal, and I think you also need to write NPTEL. So you will see I upload the lecture after the class. So it should be available around 8 p.m. every day once I complete the class. So you can search that and you will be able to see our digital circuit playlist in that.
ओके सर।
You'll see all the week's lecture there. Yeah.
इसमें तो 8 बिट होगा। 8
So it says, what is the data bus width of a 8085 microprocessor?
8 बिट सर।
Yeah, it is 8 bit. So as I said, we have AD0 to AD7, which is the data bit, and A8 to 815. So this is actually the whole thing is address, which is 16 bit, and from the 16 bit, 8 bit is the data. So the data bus width of a 8085 microprocessor is 8 bits. Let's move ahead then. So next problem is this. It says, which of the following machine cycle is not present in the 3-cycle instruction execution? So yeah, if you have gone through the lectures of professor, this is again a very theoretical question. So maybe take 1 or 2 minutes if you are able to answer that. Otherwise, I'll explain.
ये फैच होगा क्या सर?
Answer D, encode.
Okay. So the correct answer is actually option D, which is encode. So as you might have seen that what we are doing is we are performing some operations in the accumulate So I mean, let's say if I try to give an example, maybe again A at B. So what we are doing is we are initially fetching the bits A and B, right? Once we have a memory, as I said, we have a 8-bit memory, then we have given some instruction in that. So first of all, we will fetch the bits A and B. Then what we'll do, we'll try to decode those bits, that what are actually those bits. So the operation will be like, first we'll fetch, then we'll decode the bits, and then we'll execute the bits. So there is no encoding that happens actually in the 8085 microprocessor. There is no encryption or encoding happening. So the correct answer to this is encode. So these three are the actual operations or the process that is happening. And this is the flow of that. Yeah. Okay, we can move ahead. So the next problem is 8085 microprocessor can operate with which
3
clock?
megahertz.
Okay. Yeah. So again, this is a direct question. So 8085, it operates around 3 megahertz to 6 megahertz. So 3 gigahertz is a way lot higher. So it is a megahertz processor. Again, 8 megahertz is too high. So the correct answer would be option A. Okay, yeah. So I mean, yeah, this is most of it. So if you see that we have tried to cover the very basic of microprocessor, like how it does it work, instead of doing some of the actual problems of the code. So that is more or less been kept for your subsequent week. That is, I think, week 11. And if you see the course outline, so we have already covered the VHDL part, in which you were, I think, you were able to understand that what kind of a circuit we can make. So maybe, yeah, let me give you a very quick question on this. So let's say, okay, I'll give you a very easy one. Try to give the answer quickly. So we have, let's say, an entity called as design, and then in the design we have port, which is okay, let me think. Header I've already done, marks I've already done. Okay. So A is the input port, which it says 3 down to 0. B is output. Sorry, it's not port, it's bit actually. It only says bit. Then we end design. Now in the process, I'm using something called as ABS. And in this, I'm saying that if S is double equals to 0, 0, then assign B should be equals to A naught. Then I'm saying else if S is equals to 0, 1, B should be assigned to A1. Else if S is equals to 1, 0, B should be assigned to A2. Else B is always assigned to A3. And I'm doing the end process, and I'm doing the end begin. So yeah, what kind of circuit do you think this particular code is?
Four is to one multiplexer.
Sorry?
4 into 1 multiplexer.
Exactly. So I hope you're able to understand these codes now. So we have 4 inputs. We have 2-bit select line because we are using 0, 0 and 0, 1. So let's say this is the select line S1, S0, and we are calling this as 4-bit input, which is A3, A2, A1, A0, and we have a single output, which is B. So now based upon the select lines, we are connecting B to A3 or A2 or A1 or A0. So this is nothing but a 4x1 multiplexer. I hope you are able to understand these problems now, and you will be able to understand these questions. I think this some type of question that are given in your assignments too. In 8085 problems are very straightforward, so that should not take much time. So now as you can see, we have already covered some part of the course and we are almost in the last week. So in the next week also we'll be doing some of the microprocessor problem. One thing I wanted to ask, so I'm thinking of taking a additional 1 hour session that is called as week 13 1 hour session, in which I'll be giving you some of the important question and summary of this course. I mean, according to me, some of the important topics that you could emphasize on more. I mean, each and every topic is important, but yeah, there are some problems that I think are more important. So I'll try to give it in the next lecture. So per se, so we have week 10 that is scheduled for today, which is 26th of October. Sorry, not October, September. So my next lecture is actually scheduled at 3rd of October, and this 12 is scheduled at 10. So this should be the last lecture. So what I'm planning is I'll do, instead of 10, I'll take this on 7th, and on 10th I'll take the summary session. So please confirm if you're all fine with this particular schedule. So we'll still end the course on the same date, that is 10th October. But yeah, there is one more session. So the next week there will be two sessions instead of one. So this will be a 1 hour session, not a big session like we take in general of 2 hours. And these two again will be 2 hour sessions, which is related to more or less the microprocessors. So is it fine with all?
What is the
Yeah, so maybe I'll post that in
Sir,
the, yes.
will you get provide the important question in this week 1 to up to week 12?
Yeah. So I'll try to like make a PPT in which we'll have most of the important problems from week 1 to week 12. Yes.
Okay, sir.
Yeah. So I think we,
which book we can follow for this?
sorry.
Which book author, what are the author we can follow for this exam?
Okay. Book you are asking. I'm not sure. I think the book is already mentioned in the course outline, but one I know is something called as Morris Manno. I'm not sure if this is what is recommended in the course outline, but yeah, you can take a look. You can just go to the NPTEL where you submit your assignments. In the course outline, the names of books are already written, so you can take that. I mean, take a look at that.
Thank you.
Yeah. So yeah, thank you everyone for joining. I think this is all for today. We'll meet next week same time. So week 11 lecture will be as scheduled, and then in the subsequent week we'll have two lectures in total of 3 hours, and by 10th of October we'll conclude the course. So yeah, again, thank you everyone for joining.
Thank you.
Okay, sir. Bye.